going to talk about plate interactions, okay? Types of plate interactions and their results. So here we go here. Okay, so take a look right here. The surface of the Earth is broken up into 15 major plates that are a part of the lithosphere. Now, when you think of the lithosphere, think of semi-liquid rock that these plates are just kind of floating around on. Okay, and here's some plates here: Pacific Plate, Australian Plate, South American Plate, African Plate, Arabian Plate, North American Plate, Antarctic Plate, Nazca Plate, and specifically, let me show you something here. But from here, follow me up here, South America all the way up to North America, and then over here like this right here, down through right here. All this area in here is called the Ring of Fire. So from here to here, look here, from here, here, let's put that back. From that, well, anyway, from here to here is called the Ring of Fire. We'll talk more about that later. Okay, all right. So there's 15 major plates and there's some smaller plates. Okay, so here's our first question right here. So let's look and see. This is a little review here. Tectonic plates move due to what? Is it the convection currents or the volcanic activity? A or D? Mark your answer. We talked about those. Oh, yes, we did. Everybody got an answer? Okay. Okay, now, just to be sure, because this is a review, what's our answer here? This is a freebie here. What was our answer? What's our answer, Bryce? Convection or volcanic? A or D?
A.
What do you say there, Michael?
D.
What do you say there, Terry? A or D?
D.
It is A, actually, convection currents. It's those convection currents. You remember we said that some of that rock, some of the rock in the mantle, some of it's near the core, the outer core, and that's going to be the hottest rock. And then the mantle closer to the crust is going to be cooler rock. And so you got airflow in there, and that's where you get convection from, airflow. And so here it is right here. You got, it's cool, so anything cool sinks, right? Anything hot rises, so it's kind of a cycle. And those plates are going like this, like literally like that, okay? Based on the convection currents, okay? So let's look right here at plate boundaries. Plate boundaries. So we got these plates, and then there's a boundary to each plate, and then that one plate bumps up against another plate, and let's see how they. So there's 3 different ways here that they can slide into each other. So the black lines on the previous slide, and that's these black lines here. See all these black lines? These are plates. So the black lines on the previous slide are dividing lines between each of the plates. All right? And so any 2 adjacent plates, that means the ones next to each other, can interact in one of the following ways below. They can either bump into each other, go toward each other, they can go away from each other, or they can slide past each other. Okay? Slide past each other. All right. So let's look at the first one here. Where the 2 plates are pushing against each other, that's called convergent. Okay? Convergent boundaries. And convergent plates collide. Boom. Boom. Right? Ooh, and that's the heavy earth. That's the plates of the earth. That's a lot of power when you got 2 plates bumping up against each other. Something's going to happen, I promise you. And you'll see here shortly, there's several things that can happen. Okay? Okay, so let's look at the types of convergent boundaries there are. If you look right here, there's the ocean continental, there's continental continental, and then there's oceanic, okay? So, let's look right here. So oceanic continental, look what happens here. What do you get out of this? If you got an oceanic plate converging or hitting, bumping up against a continental plate, guess what happens? The oceanic current goes down here, and that basically opens the place up for what? Volcanic activity. Okay? And then, look right here, you've got continental plates, they bump into each other and they're thick, they're very thick and they're very powerful, and guess what happens? Look what happens here. When they bump into each other, you get what? Mountains, okay? That's, by the way, how the Himalayas form. We'll talk more about that later. And then you have oceanic, and here you can get volcanoes, and sometimes you get earthquakes also, okay? Matter of fact, even if you get a volcano, I promise you're gonna get an earthquake out of the deal too. Okay, oceanic. Oceanic plates are thinner, continental plates are thicker as a general rule. Okay? So 3 different types of convergent plates, and those are the ones that bump into each other. They come together. Okay? Okay, so let's look right here. Let's look at something called subduction. You know what a submarine does, right? What does a submarine do? Goes under the water, right? Sub means under. So, as you can see in the picture on that previous slide, oftentimes when 2 plates converge, one tectonic plate moves under another, right? That's what happens. That's what happens here with the oceanic, and also happens with the oceanic and the continental. The continental plate's thicker, so the oceanic plate is going to give, and it's going to what's called subduct. Okay, it's going to subduct. So that's what subduction is. So when that happens, when one goes underneath the other, that's called subduction. Okay. And then you have, so here you got convergent boundaries. Anybody know? Well, this just tells you right here what it is: a blank map of India. This is a blank map of India. Geographers recognize that India is what's called a subcontinent, okay? That means it's below, right? Below the other continents. That doesn't mean it goes underneath the water. But subcontinent means it's a smaller continent. Anyway, so one example of a convergent boundary is between the Indian plate and the Eurasian plate. So you have, here's the subcontinent of Asia. Now these are continental plates, right? Here's a continental plate, there's a continental plate. What's going to happen? What's going to happen?
Combine.
Mountains. You're going to get mountains right out of the deal. And guess what you got right here? Anybody know what this area is right here? Right along here? The Himalaya Mountains. They are the tallest mountains in the world, and something cool about mountains. The taller the mountains are, guess what? The younger they are. The Himalayan mountains are the youngest mountains on Earth. Okay, the Wichita Mountains out here, the ones we got right out here north of us, north and west of us, those are some of the oldest mountains in the world. Those mountains out there are almost, they're like 500 million years old.
So they're older than other states' mountains?
They are, yes. They're older than the Rockies. If you go to like Colorado, the northern part of New Mexico, you have the Rocky Mountains up there. Those are relatively young mountains too for the United States. Okay, so anyway, so when you got these 2 continental plates that bump up into each other, let's see if we get another, we'll get some more pictures here out of here shortly. So here you got these convergent boundaries. So scientists hypothesize, that means an educated guess, right? You remember that word, hypothesis? They hypothesize that the Indian plate slowly moved closer to the Eurasian plate until it finally collided, and this shows the motion of here it was down here earlier. Boom! This was 71 million years ago, and then it's moving on up 55 million, 38, 10. India today, they're bumping up against the Eurasian plate, and that's what causes the mountains there, the Himalayan mountains. Okay, got the idea? Makes sense. Okay, so when two continental plates collide, what are sometimes formed? Mountains or landslides? B or D, mark your answer. Two continental plates collide, what happens? Do you get landslides or mountains? Mark your answer, that should be an easy one, you should not miss that one.
I'm gonna laugh at him, Mr. Hughes.
Huh?
I'm
You can
gonna
laugh at them, okay. I'll buy that. All right, are we ready? Okay, so let's look right here. So what do the arrows on the diagram represent? Look here, you got, here's this going this way, these going this way. Does this represent plate movement or volcanic eruption? What do those lines represent? Plate movement or volcanic eruption? C or D, mark your answer. You can't choose A or B. What are those two, what are these, if you see this on a map, what's that mean? What are those plates doing? Are they moving or are they having a volcanic eruption? Everybody got an answer? Okay, that was such an easy one. Okay, so let's look here, again, we're gonna talk a little bit more in depth about the collision of plates. So how were scientists able to come up with this hypothesis that the Indian plate collided with the Eurasian plate? And you can see right here, here's China, here's India, and in between China and India are, you've got, way up here you got Pakistan, but right here you got Nepal, there's another little country in there, and then you got Bhutan. But right here, along this line here is the Himalayan mountains. That's the Himalayas, okay? And they spill over into China, by the way. China on the north side. So if you climb the Himalayan mountains and you start going down on the north side, guess where you're gonna wind up? You're gonna wind up in China. Okay? So the proof scientists used, again, this is how were they able to come up with this hypothesis that the Indian plate collided with the Eurasian plate? Well, the proof they used was found in the features. In this case, the Himalayan mountain range found among the northern border of India. Okay, so that's that area there. Okay, got the idea? Okay, so let's look right here. So, and this is another way how they figure this stuff out here. So, look right here. What happens when plates converge? Well, a mountain range slowly forms as tectonic plates converge and they collide. Look here. So they hit, and then this is a gradual process over millions and millions and millions of years. And the Himalayan mountains are still growing, by the way, because the Indian plate subcontinent is still bumping into, colliding with the Eurasian plates to this very day. And so those mountains are still growing. Matter of fact, Mount Everest is noted for being the tallest mountain in the world. Well, there's a mountain right next to Mount Everest that's like 3 feet higher. I think it's called K2. Anyway, so a mountain range slowly forms as tectonic plates converge. Converge means they coming together. So the collision is similar but much less sudden and dangerous than a head-on collision between two cars. You know how it is when two cars, they hit head-on, right? What happens to their hoods?
Come up.
They buckle. That's called buckling. They buckle up. Same way mountains do. When two continental plates collide, they buckle. And so mountains are formed. So this car's been in a head-on collision. And you notice that the hood's buckled, right? So what specifically caused that to happen? Well, they meet, and the only thing they can do is go up. Okay, so look right here. So as two continental plates, such as the Indian and the Eurasian plates, converge, the land begins to fold up and buckle, just like the hood of the car on the previous slide. And unlike with car crashes, this transformation takes thousands or millions of years. Okay. What's even more interesting is that the mountains you see below are still growing as the two plates continue to converge. Okay. Okay, we're not doing that worksheet. Okay, so let's talk about divergent plates. So we talked about convergent plates, and those are the ones that are moving toward each other. Now let's look at the ones that are moving away from each other. What's gonna happen when you got a plate that moves away from each other? What's gonna happen?
You're gonna fall through.
Oh, you could fall down, right? Literally fall through. Okay, so a divergent boundary marks two plates that are moving away from each other, right? Away from each other. Divergent plates divide, right? DI, divide. Divergent, divide. Okay, they move away. Okay, so let's look at a divergent boundary. And you see right here, here's Africa. Up here's South America. Up here, there's Florida right there. So here's the North America. Here's Iceland over here. And you have something right here in the middle. This is the Atlantic Ocean. And you have something called the Mid-Atlantic Ridge. Well, this is an example of a divergent boundary, and it's found right smooth in the middle of the Atlantic Ocean. Okay, let's see what it looks like. So, you get something called, with divergent boundaries, you get something called seafloor spreading. Okay, so seafloor spreading is a result of divergent boundaries. Okay, they're moving apart. So it's the process by which new oceanic crust forms along a mid-ocean ridge. When I think of a ridge, I think of it going up a little hill, right? Kind of like that. That's what it looks like. So as the plates separate, magma from below the surface emerges. What's magma? Oh my. That's the hot stuff from the mantle, right? Comes out. So it flows into the seafloor and cools. Okay? Flows into the sea. And so this pushes the older oceanic crust away. Okay, so as this comes out, it pushes this stuff that way, right? Pushes this stuff that way. Okay. Okay, so here we go. Here's another question here. New oceanic crust forms and old oceanic crust moves away from a mid-ocean ridge during what? Continental drift or seafloor spreading? Mark your answer. Don't miss that one.
So read it again.
Yes. New oceanic crust forms and old oceanic crust moves away from a mid-ocean ridge during what? Continental drift or seafloor spreading? A or D? Mark your answer. What were we just talking about? Everybody got an answer? Okay, let's move on. Okay, so what would the oldest, where would the oldest oceanic crust be found?
The what?
A, B, C, or D? Mark your answer. Where's the oldest going to be found?
The ocean.
Where's the oldest going to be found? Here or over there? Here or there? Mark your answer. A or D? Mark your answer. Okay, I'm gonna move on. Okay. Let's talk a little bit about transform boundaries. So a transform boundary occurs where two plates slide along each other. Look here. We're sliding along each other. Now, it's not like that. It's not easy like that. Look here. They're and they get hung up, and then, woo, what happens, do you think, here, when this happens?
It's gonna go away.
Earthquake.
Yeah.
I promise you, an earthquake. Okay, we'll talk about that. So these transformed boundaries travel past each other. Transform travel, right? Travel past each other. So which of the following is a type of plate boundary? We talked about three. There's three answers. Which three did we just talk about? We talked about three. T, C, and D. Mark your answers.
You said what?
Mark your answers. We talked about three types of plate boundaries. There's three answers there. Mark three answers. Which three did we just talk about? We talked about three of them today. Mark the letters. There should be three letters that are correct. Okay, everybody got an answer? Is this easy?
Mhm.
Michael Cardell, you got an answer? Huh? Okay. Okay, so, let's talk a little more about transform boundaries. Okay, so transform boundaries, let's look right here. So one example of a transform boundary is the San Andreas Fault, which runs through California. You can see this picture right here. And it's the point where the Pacific and North American plates meet. Okay, here on this side right here is the Pacific plate. On this side of these right here is the North American plate. Pacific plate, North American plate. Okay? And we'll watch this video shortly. I can't show a YouTube video for you who are watching this video. I'll try to put a link to it later. And I think we're gonna stop our lesson right here for the day. I'm gonna stop the lesson here, and we'll talk more about transform boundaries a little later.